On this video, I'm going to show you how to solve using square roots. So I'm going to tell you why this tactic is actually the best way for these types of problems. So most quadratics are typically you have an x squared and maybe like a 2x minus 8 equals 0. With these types of problems, you're going to want to use one of the other techniques. Why you want to use one of these is notice how there is two x's in there. So when those, you're going to look at one of these other formulas. Whenever I see just a single x there, so like an x squared there, this is when I start thinking about using square roots to solve the equation. So if I'm wanting to solve this for x, what I'm actually going to be doing is, if I'm going to be working and solve this, I want to do the order of operations backwards. Meaning, while I'm trying to get x all by itself, or get x isolated, I want to get rid of any addition subtraction first, then get rid of any of the multiplication division, then worry about exponents, and then last work inside the parentheses. So if you're solving and trying to get a variable all by itself, we're always trying to work order of operations backwards. So in this first problem, I have 2x squared minus 64 equals 0. So trying to get this x all by itself, the first thing I'm going to do is I'm going to get rid of this 64 and move it to the other side. So I'm going to add 64 to both sides. That's going to leave us with 2x squared equals 64. After I got rid of that subtraction, the next thing I want to do is I want to worry about getting rid of this 2, because that's 2 times x squared. The opposite of multiplication is division, so I'm going to divide both sides by 2. That's going to give us x squared equals 32 when you do 64 divided by 2. So now I'm almost to getting this x all by itself. I just have that square with it. So our next step in trying to get that x all by itself and solve this quadratic is, if I have a square, I want to do the square root. Again, if you do the square root of one side, you're going to have to do the square root of the other side. Because when you take the square root of a square, those are inverse operations, so we're left with x. On the other side, I have this square root of 32. Now, some of you might immediately reach for a calculator there and try and figure out the square root of 32. It's going to come out to some decimal. What we want to do is we want to find a way we can simplify this, because we want a precise answer. So if you're going to do the square root of 32, what we're actually looking for is, we're looking for, what numbers do I know the perfect square of? So what numbers can I take the square root of? Those are numbers like 1. I can take the square root of 1, that's 1. I can take the square root of 4, that's 2. Square root of 9, that's 3. Square root of 16, you get 4. Square root of 25, you get 5. You get the idea. So we're looking for numbers that we can take the square root of. So what I want to do is I want to rewrite this 32 using one of these numbers. And I want to find the largest number here that divides into 32. The largest number here that we can divide into 32 is actually going to be 16. So what I'm going to do is I'm going to rewrite this. Instead of writing the square root of 32, I'm going to rewrite this as 16 times 2. Now these are the exact same thing, because 16 times 2 is 32, vice versa. So all I did is I rewrote the inside here. When I'm going to take the square root now, I could take the square root of 16. The square root of 16, we're going to get positive and negative 4. Then I have to take the square root of that 2, but the square root of 2 is not something that we know. It's going to be some sort of decimal. So instead of taking it outside the square root, I'm going to leave it on the inside. So all I did is I went down, isolated my x, took the square root, and then I have to simplify the radical, or simplify the square root. So I broke it up into a number I can take the square root of times some other number to get 32. So we get x equals plus or minus 4 square root of 2. Another example that we can look at here is, I have z minus 6 squared equals 25. Again, I'm still trying to work the order of operations backwards. So I have this minus 6 and I have a square. I cannot address this minus 6, even though you're saying, oh, we have to get rid of addition subtraction. I can't address that 6 yet because we're inside parentheses, and that's the last thing we want to do. So the first thing I'm going to do is actually deal with the exponent. So what I'm going to do is I'm going to take the square root of both sides. Just like before, when you take the square root of a square, those are inverse operations. So we're left with z minus 6. On the other side, I have the square root of 25, and we should be able to do that in our head. The square root of 25 is going to give us positive and negative 5. So we have two different numbers here, positive and negative 5. To try and keep myself a little bit more organized to get the right answers, I'm going to split this up, meaning I'm going to have z minus 6 is equal positive 5, so I took care of the positive part. And I'm also going to rewrite it and put z minus 6 equals negative 5, so get that negative part of the problem there too. Now I just need to solve each of these problems individually using Algebra 1. So if I have z minus 6 is equal to 5, I'm going to add 6 to both sides. That will give us z equals 11. Over here I have z minus 6 equals negative 5. I'm going to add 6 to both sides, and that is going to give us z is equal to 1. Both of these answers are our solutions to this quadratic. Quick review, why we're using solving by square roots is because I see x show up only once in our equations down here, and z, so our variable is only showing up once. That usually is a hint to me that I can solve by square roots.